everyone, welcome to this video. In this video, we want to look at how we can calculate the equilibrium concentration if we have been given the volume of the vessel that was used and the initial masses of the reactants. Before we can even look at how we can do this calculation, don't forget to subscribe to our YouTube channel, Zuluba Consultants, and our Facebook page, Zuluba Consultants, for this and more videos. If you find this video very beneficial, don't forget to like it. That is the best way we can get feedback from you. So let us look at the question that we have. The question reads, calculate the equilibrium concentration if a 5.00 liter vessel initially containing 15.7 grams of hydrogen and 294 grams of iodine. The K value we have been given that K is equal to 7.1 times 10 to the power 2. So what do we need to do as we are performing this calculation? Well, the first thing is we have the equation here that is guiding us of what is happening in this reaction. So we have the reactants there and the product there. Now, you notice that in this equation, we have not been given the initial concentrations of the reactants. For the product, we have no problem. We know that this is when the reaction was starting. So for the product, the initial concentration is 0. But for the reactants, how do we get the initial concentration? Well, the 2 grams that we have should help us to get the initial concentrations for the reactants. So we have to use the 2 grams, that is the 15.7 for hydrogen and the 294 for iodine. With the volume, this should help us to find the concentration. Now, how do we calculate concentration? We say concentration is equal to the mass of a given reactant divided by the mixture of that reactant multiplied by the volume of the vessel. So if you have that as the formula for concentration, what are we going to do in this question? Let's start with hydrogen. What information do we have about hydrogen? We know that the mass for hydrogen is 15.7 grams. We also know the mixture for hydrogen gas. This we get it from the periodic table. So the mixture for hydrogen gas is 2.02. That is the mixture for hydrogen gas. What else do we have regarding hydrogen? We have the volume, that the volume is 5 liters. So we are going to use these 3 information to calculate the concentration. So how do we get the concentration? We'll say concentration is equal to the mass is 15.7 divided by 2.02 multiplied by 5. So if we multiply 2.02 and 5, then we divide it with the 15.7 that we have, we should get 1.56 m as the concentration of hydrogen. So this is the concentration of hydrogen that we have found. Let's look at now for iodine. The iodine, what data do we have? The information that we have is the mass for iodine. We have been given it is 294 grams. The mixture for 253.8. 253.8. Then we also have the volume. The volume is the same, which is 5 liters. So what are we going to do with this information now? We are going to use the very formula for finding the concentration, where I will say concentration now for iodine is equal to, the mass for iodine is 294. We are dividing this by 253.8 times 5. So if you punch this on your calculator, it should give you 0.232 m. So 0.232 m. So we know that this is now the initial concentration of hydrogen, then this is the initial concentration of iodine. So we can come now back to our table. So after we know the initial concentrations, we can put these initial concentrations on our table. So for hydrogen, we have 1.56 as the initial concentration, while for iodine, we have 0.232. Remember, when this reaction is starting, the product is not present. So the concentration of the product will not be there. Now, what will be the change? The change will be corresponding to the coefficient of each reactant or each product. Now, what do we mean the coefficient? We simply mean the numbers that are this side. So, for the reactant, we have 1 this side, then 1 here. So this simply means the change of the reactant will be a negative x because of 1 there. And for iodine also it will be a negative x. This negative x will be the change for the reactants. Now what will be the change for the product? If x is the variable that will change, then for the product it will be 2x in terms of concentration. So for the products it will be 2x. Now how will be this situation at equilibrium? At equilibrium then it will be 1.56 minus x for hydrogen, then 0.232 minus x for iodine, and positive 2x for the product. Now that we have reached this far in our calculation, we now have to write the equilibrium expression for this reaction. Now, what is the equilibrium expression for this reaction? The equilibrium expression for this reaction is K is equal to the concentration of the product, with the exponent there, that will be to the power 2, then divide by the concentration of the reactants. So this is the equilibrium expression. Now, why are we writing the equilibrium expression? We want to use the equilibrium suggested values to come up with the value of x. Now, from the question, we have the value for k, which 710. When you remove the scientific notation there, you'll find that this is 710. So 710 is equal to, what is the equilibrium concentration of the product? For the product, we have, it is 2x. So we'll put our 2x there. This is to the power 2. Divide by the equilibrium concentration of the reactant. For hydrogen, it is 1.56 minus x, then 0.232 minus x. So this is the equilibrium expression that we have there. So if we now make this into an equation, we should have 710, open bracket, 1.56 minus x, then 0.232 minus x, minus, this is same as 4x squared, should be equal to 0. When you do your mathematics nicely here, you'll notice that you should have 706 to the power, 706 x to the power 2 plus 1272 x plus 257 is equal to 0. Now, you'll notice that if you reach this far, you have, this is A, this is B, this is C. So, if you make this equation, you can now solve this equation using the quadratic equation. So, in this video, we're not going to show you how to solve this equation using the quadratic equation, but we'll provide you with the values of x that you get if you use this equation as a quadratic. So the possible values of x that you get are, one is 1.57 and the other one is 0.2317. Now, if you get those two values, one might ask, why have we even gone this far? There is a very important reasoning that is given. When you have been given such a question, and you look at the K value, if the K value is very large, it simply suggests that one of the reactants was almost consumed. So if one of the reactants was almost consumed when this equation reached to equilibrium, the K value is very large. And when the K value is very large, we go the quadratic equation way when you are solving the value of x. These two as your answers. We want now to look at how do you pick the answer to use when you want to calculate the equilibrium concentrations of the reactants and the product. When you have these two values, x is equal to 1.57 or x is equal to 0.2317, you need to look at the values of the initial concentrations that you have. So for the reactants, you will notice that for hydrogen, the initial concentration that we calculated is 1.56. Now if we say x is equal to 1.57, what does that mean? It simply means that the final concentration of the reactant will be a negative answer, because this is bigger than the initial concentration. Now, we can never have a negative concentration. So this simply means you cannot use this as your value of x. So we will use now the second value as the value of x. So we now know that where we have x, we can put that value 1.56 minus 0.2317. You get 1.33. 232 minus 0.2317. You get 0.00022. Then, for the value of the product, we are saying x should be multiplied by 2. So if you multiply this value by 2, we should get 0.464. So this is the concentrations that we are getting as the final concentrations. So if you have been asked, calculate the equilibrium concentrations when you have been given the mass, these are the answers that you have been demanded to provide. So let us now summarize. Hydrogen, we are saying the concentration is 1.33 m. For iodine, the concentration is 0.00022 m. And for Hi, the concentration is 0.464 m. So these are the concentrations of the reactants and the products at equilibrium. Hope you enjoyed watching this video. Don't forget to subscribe to our YouTube channel, that is Zuluba Consultants, and our Facebook page, Zuluba Consultants, for this and more videos.